Okay, so we're going to look at some problems from exam number 4. Um, Hopefully they'll be helpful as I go through them rather quickly, and maybe you can practice them enough to get more and more familiar with them before you take your final. Here was one of the questions. Under standard conditions, what is the density of neon in grams per milliliter? So under standard conditions, um, there are a couple ways to do this problem, um, but the first one would involve taking the molar mass of uh, neon in grams per mole, and then understanding that under standard conditions, the volume of 1 mole of a gas is going to be 22.414 liters, so that many liters per mole, and then converting that from grams per liter into grams per milliliter. So one way to start that off would be simply to start off with your molar mass for neon, 20.1797 grams of neon in a mole of neon, and then convert or use the Avogadro's molar volume of a gas to get from moles there, cancel it out, and liters on the bottom. So you put them 1 mole up top and let that cancel out with these mole down here, this mole down here, and you'd end up with grams over liters. And then convert liters into this milliliters up here. So 1 liter of neon would be 1,000 milliliters of neon. So the density in grams per milliliter would be 9.0032 times 10 to the minus 4 grams per milliliter. And it depends on again, what you're going to be limited to would be, I don't know if I use the exact same periodic table as you, but this has 5 sig figs, and the molar mass for neon that I used here had 6. So when you carry that through, this is infinity, so you would end up with 5 sig figs reported there. Or base that on however many is on the periodic table that I gave you. Another way to do that is, if you want to find the density, it comes out in grams per liter at first. You have pressure times molar mass divided by RT, and I gave you a way to remember that that was some of y'all thought was pretty funny. But you do that. I used a pressure of 1 atmosphere, the molar mass from the previous problem. I use the R that goes with atmospheres, and I use standard temperature. And I got this in grams per liter. I converted it to grams per milliliter, and it comes out to be the same thing. And then either way would get you to the same spot, is what I'm trying to say. So that's one question that you could see on your final. Another question that you could see on your final exam would be one like this. Calculate the volume of oxygen required to react with sulfur dioxide under standard conditions to produce 85 milligrams of sulfur trioxide gas. So something like that, you need to first write the equation for the chemical reaction and then balance it. So you would start off with something like oxygen gas plus sulfur dioxide gas yields sulfur trioxide gas, and then you got to balance that out, and your coefficients are 1, 2, and 2 when you do so, followed by calculation of everything. So here you have your 85.00 milligrams that you're starting out with, and that's very important. Your milligrams starting out, and right away you need to convert that to grams. So that would cancel out, and you'd be in grams of the sulfur trioxide over here. Now you convert the grams to moles using your molar mass from the periodic table. So the grams part goes on the bottom once you calculate that, and you'll end up with moles of SO3. And since you have a balanced chemical equation for your reaction, your moles of SO3 can be used to convert to moles of oxygen. So the coefficient of 2 moles of SO3 to 1 mole of O2. And then since we're talking about at STP, well, 1 mole of O2 at STP should occupy a volume of 22.414 liters. Then you need to get that volume to be in milliliters. So you convert it to milliliters. And you multiply across the top and divide by the bottom. And looks like I was going with 4 sig figs because of that measurement, and all the other things that I used. Either the molar mass had more than 4 when I did this with my periodic table, and the molar volume has 5. So 4 sig figs, 11.90 milliliters of O2 gas. Then on this one, you have this Celsius temperature, which will have to be converted to Kelvin. You have a pressure in torr. What is the noble gas's identity? Well, you're given the density in the problem, and I gave you an equation for that. If you want to solve for the molar mass, then you can, and you have the density, you can divide the density times R times T by the pressure. And I gave you another, which some of you thought was funny, little way to remember that. So you substitute now these things into the problem. This is the density from the problem. This is the R value from my reference material, gas constant R values. And then this is my temperature converted from Celsius to Kelvin. And then I can use the pressure in torr. And I came up with around 84.0 grams per mole. And since I know it's supposed to be a noble gas that I'm supposed to answer, it looks like it's closest to krypton on the periodic table. So I would go with krypton on that one.